Welcome to today's lectures. So today we will study this topic, combined gas laws. So what is this gas law? It is a gas law that combines Boyle's law, Charles law and Amanteur's law. So it is purely an amalgamation of the previously discovered law that we have discussed. These laws each relate one thermodynamic variable to another. So mathematically, while holding everything else is constant. So previously laws were that Boyle's law, Charles law, Amanteur's law. So these were the amalgamation of these three laws. The interdependence of this variable is shown in the combined gas law, which states that it is the ratio between the pressure volume product and the temperature of a system remains constant. So these are some conditions. So we can say mathematically PV by T equal to constant. What is P? P is pressure, V is volume, T is temperature, and where K is the constant. So this is the constant, this is the given here. So for comparing the same substance under two different set of conditions, we can see this law in different format like this one. P1 V1 by T1 is equal to P2 V2 by T2, like the previous gas laws, P3 V3 by T3. So addition of Avogadro law here, one thing you have to keep in mind, addition of Avogadro law to combined gas law yields the ideal gas law. So here we are not combining this Avogadro law to this one equations. Derivation of the gas law. So derivation gas law, we know Boyle's law equal to PV equal to constant, Charles law equal to V by T equal to constant, and Amanteur's law equal to P by 3 equal to K3 equal to constant, where T is the absolute temperature of the ideal gas. So if you divide this equation 1 by T, so you will get P1 PV by T equal to K1 by T. Similarly, if you divide PV by T equal to K2 into P, so you will get this one equations. So you will get the equation 5 by 2. So here PV by T equal to K2 into P. Now you can see equation 4 and 5. This and this, these two are constant. That is K1 by T equal to K2 into P. So which is obviously means P by PV by T equal to constant. So these are constants. So in this way, these two laws are written like this one laws, PV1 by T1 like this one constant under the one set of condition, that is the moles constant like this one. So this is the combined gas laws. Now let us see some problem based on this combined gas laws. 35 ml of oxygen were collected at 6 degrees centigrade and 758 millimeters. So calculate the volume at STP. So this is the volume given V1, V2. V2 we have to find out, T1, T2 is given, P1, P2 is given. So P1 V1 by T1 equal to P2 V2 by T2. This is the combined gas laws. So this is your combined gas laws. So we'll get, by putting this value, so we'll get V2. So V2 equal to 34.28 ml. So this is a very easy calculation. If your mathematics is strong, then you can solve these values. Second is calculate the amount of potassium chlorate which must be heated to produce 2.4 liter of oxygen at 740 millimeter of mercury and 25 degrees centigrade. So this is given P1 V2, P1 P2 V1 is given here. V2 we have to find out. T1 is given here, T2 is also given here. So using the combined gas law, P1 V1 by T1 equal to P2 V2 by T2. So from here we will get V2 equal to, by substituting all the values, we will get 2.1408 liters. Now they are in question is asking what is the amount of KClO3. So we have to find out the amount. So first you write the reaction of KClO3. So on heating KClO3, what will happen? It will decompose into potassium chloride and oxygen. So 2 moles of potassium chloride is giving 3 moles of oxygen. 3 moles means 3 into 2.4 liter. So write the molar mass of KClO3. So we are getting 245 gram. So 2 into 22.4 liter of oxygen is for the release of this much gases we require 245 gram of KClO3. So if you require 2.1 liter of oxygen, so how much KClO3 required? So by using unitary method, 245 divided by 3 into 22.4 into multiplying by 2.1408, so we'll get 7.8 gram of potassium chloride. So we require amount of potassium chloride is 7.8 gram to release this one 2.1 liter of oxygen. So in this way we can find out. So let us see one more problem. A gas occupying a volume of 100 liter is at 20 degrees centigrade under a pressure of 2 bar. What temperature will it have when it is placed in an evacuated chamber of volume 175 liter? The pressure of the gas in the chamber is 1/3 of the initial pressure. So things given, so we can write all the given values. P1 is this much, P2 is this much, V2 this much, V1 this much, 100 liter, V2 175 liter, T1 given 293 Kelvin. We have to find out T2. So use the combined gas laws. P1 V1 by T1 equal to P2 V2 by T2. So solve all value, put all value. So after substituting all values, so T2 will get 170.9 Kelvin. So in terms of centigrade, so subtract this whole Kelvin by minus 273, you will get these answers. So there is one more questions. At 25 degrees centigrade and 760 millimeter mercury pressure, a gas occupies 600 ml volume. What will be its pressure at a height where temperature is 10 degrees centigrade and the volume of the gas is 640 millimeter? So here pressure is coming 676.6 millimeter of mercury. So you practice this question. This question I am not solving it.